Hey everyone, today we are going to be going over this experiment 7, and it's going to be over AC voltages, frequency, and how to use an oscilloscope. So we'll start off by just getting familiarized with some of the equipment, and then we will take some measurements, make a little drawing, and yeah, just kind of learn how all this stuff works right here. So what's important in this lab is that we're going to be dealing with AC currents in this one instead of direct current, like how we have done in previous labs. So instead of using this power supply right here, we'll be using a function generator, which will put in AC voltage through our system, and we'll sort of measure that, see how it's different. So what we're really going to start with here, though, is this piece of equipment. This is called an oscilloscope, and so this is what we actually use to take our measurements. So we'll go ahead and power this oscilloscope on, and the first thing that you will notice is we can see this line that's going straight across this screen right here. So that's just kind of reading no voltage going through our system right now. So you can use some different things on our oscilloscope to be able to move this line around. There's this position knob that'll move it up and down. There's a horizontal one that can move it left and right. So you can kind of move it around to get wherever you need to be to have a nice picture on there, make it easier to read. So we also have this intensity button. This just brightens or darkens what we're looking at. But what's really important to note is sort of how to take readings on this thing. So if you look here, there's these little squares that are going to be divided up on the screen that we're looking at here. And so we're going to refer to each square as a division. So what we're really looking at here is that along our x-axis we're measuring time, and our y-axis we're measuring our voltage. So we're seeing how the voltage changes in time is really what we're measuring here. And so each division going this way is some time division along the x-axis, and so vertically it's some voltage division. So we can change the scale for how we're measuring these divisions. So the first thing we're going to look at is this seconds per division knob. So this changes how many seconds each box is representative of. And so what we want to do is we'll change this to 0.1 seconds per division. So we're seeing this beam go across the screen, and so each time it passes through a division, that's taking 0.1 seconds. So that passes through, and if we were to change this to maybe say 1 millisecond, well, now the beam is moving so fast that it appears to just be a solid line. Technically, it's still passing through there like it was before, but the rate is just so rapid that we can't see it moving anymore. So that's really all we need to know for part 1. You're going to be asked to make some calculations, some measurements, or not measurements, just calculations based on how the seconds per division portion of that control works. So we'll go ahead and move on to part 2. And for part 2, now we're going to bring in our function generator. So our function generator is what's actually going to output our signal, provide voltage into this system. So we'll take this cable from the output, and we're going to hook it into channel 1 of our oscilloscope. And so we just hook this in here. We have our oscilloscope set to be able to read this, and now we'll go ahead and power on our function generator. So we can see we are now getting some kind of signal on our oscilloscope. It's not just a flat line anymore, and we can change this. Right now we have a sawtooth wave, but we could change it to look like just a sine wave. We could have kind of a square pulse here, but we're going to go ahead and for this lab we're going to be reading it with this sort of sawtooth jagged wave here. And now want to have this set to about 1 kilohertz, so we're right at about 1,000 hertz right now, so that's where we want to be. And then we're going to get this lined up here so that we're reading about 6 volts total plus or minus. So we'll have our volts per division set to 2, so that means each square that we're looking at is 2 volts. So we need to go 6 volts up and 6 volts down to be at plus or minus 6 volts. So we can adjust this knob a little bit and try and get this lined up. We have this output level on our function generator that can increase and decrease the size of our wave. So we'll increase this until we have this nice wave that goes 6 volts up and 6 volts down. And we'll sort of get this positioned right here. Perfect. Okay, so we have this wave that we're looking at. We have the plus or minus 6 volts. We have it on 1 millisecond per division. And the first thing you would do is just sketch this wave that we have right here. And so you would sketch this wave, and then what we want to now do is add a second channel in. And this is going to be connected to this TTL portion of our function generator, which we will then hook into channel 2 of our oscilloscope. And now we will set our oscilloscope to be able to read or display both channels at once. And now we see we have another signal coming through, these sort of dashed lines that you can see in between the peaks of our signal from channel 1. So the next thing we would do is sketch what this part of our signal looks like. And we should note that changing the output level doesn't change the peaks or the second channel. That TTL pulse is automatically generated, and we don't have a way of adjusting that. So all you're going to do is sketch these 2 different waves. We can upload a picture of what this would look like, so you don't just have to rely on this video. And then you're going to have a worksheet that you're going to fill out in addition to this, that you'll just sort of make some, you'll answer a few questions, and that's going to be it. This was really just getting you familiarized with this equipment, so hopefully after this video you sort of understand how to use a function generator and an oscilloscope. That's everything for today. Thanks.